go ahead and just turn it in and jump right in with our discussion. We are going to be graphing these now. So what we did the last chapter was factor and multiply polynomials. What we are going to do for this chapter is we are going to graph quadratics. That's what they're called, quadratics. Okay, so we're graphing some quadratics. Let me add a thing here. Okay. And that's what you can put on that graph paper that I gave you, quadratics. Okay, now it's called graph. Okay, we're going to have a vertex form for quadratics as well, as we did for absolute value. And it's going to be y equals a, parentheses, x minus h squared plus k. Now, hk is going to have, just like with absolute value, hk is our vertex. A is our stretch. And unlike with absolute value, we're going to square. Okay, so there's one more thing though. X equals h is going to be our axis of symmetry. So there's one, well actually I think we had that for absolute value. And this thing is not cooperating. Axis of symmetry. Axis of symmetry. This is kind of stuttering on me. So, all right, anyways, we're going to graph. So on the first graph, this is why you need that graph paper. So at the one at the top left, you're going to write down y equals x squared. This will be our first graph. This is our parent function. So our h is 0 because it's not there. Our k is 0 because it's not there. So my vertex is what point? 0, 0. So that's where I'm going to start. So I'll plot at 0, 0. And then, like we did with absolute value, I'm going to have to think I'm squaring. Okay? So follow along as I do this, and do it as I do this. So I've plotted my vertex. Any questions why I plotted there? Now if I go right 1, what's 1 squared?
1.
So I'm going to go up 1. Let's go ahead and do that. If I go right 2, what's 2 squared? 4. 1, 2, 3, 4. I go up 4. If I go right 3, what do you think I'm going to do? 3 squared, which means up 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so I went to the right sum. That's plenty. If I go right anymore, do you sense I'm going to get off the graph?
Yeah.
Okay. If I go left 1, now we have to be very careful. What's negative 1 squared?
Negative 1.
Nope. Negative 1 squared is 1. So I'm going to go, if I go left 1, I'm going to go up 1. What if I go left 2? So negative 2 squared is 4, so I'm going to go up 4. 1, 2, 3, 4. And then if I go left 3, it'll be up 9. And that gives me my graph. And now this should be nice and smooth. Okay? So that was our first graph. This was our parent. Okay? This is the parent. And all the rest of them we're going to do are the children. Okay? We're basically going to change this parent a little bit. Okay? And then get a new graph from it. So any questions how we got the parent graph? Now, let's label a few parts. This right here was our, what was the name I gave it?
Vertex.
Vertex. That's our vertex. And then this right here down the middle is axis of symmetry. And that would be, in this case, x equals 0. because h was 0. Okay? Let's do another one. Can I erase this? For those of you who are with me on this? Okay. Let's do a parent, or a child now. Let's try y equals x plus 2 squared minus 3. Okay, x plus 2 squared minus 3. What is h?
2.
Careful. Negative 2.
Oh.
Because in our vertex form, just like with absolute value, do you see this symbol right here? I have to switch the sign. So we switch the sign on h. Not on k, just on h. Okay, so h is negative 2. What's k?
Okay.
Well, it's a number.
1.
Okay, let's look at this vertex form once again. Let me give you a different one. Let's do plus 7. Okay, what is h? 5. Okay, in that example. What is k? 7. What is a, my stretch?
2.
2. Okay, let's go back to my example. What's k?
Negative 3.
Negative 3. Okay, so, and what's a? What's my stretch? 1. Okay, so where am I going to start my graph?
Negative 2, negative 3.
Negative 2, negative 3. That's right here. Okay, now from there, if I go right 1, what's 1 squared? 1. So I'll go up 1 from where I started. And of course, this thing is not going to cooperate with me because it's bonobo. It needs a helmet. If I go right 2,
2 squared.
which is, so I go, now watch how I count. 1, 2, 3, 4. When we did absolute values, sometimes you guys counted wrong. And then if I go right 3,
3 squared.
3 squared is,
9.
so I count up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if I go left, do you see how the left-hand side is just reflected? It's the same exact thing. Hopefully you see that. And then I connect the dots. Nice and smooth. Left to right. Any questions on that one? Notice how I'm squaring it. Yes, I can see that. Okay, let's do another child. So are we going down our graph or left on our graph? On our graph paper. Do we go down? Okay, so we're on the third one down. So let's do this child. Y equals, hopefully you can see this. Let's do 2 parentheses x plus 1 squared. That squared's important. Minus 5. What's my vertex?
Negative 1, negative 5.
Negative 1, negative 5. What's my stretch?
2.
My stretch is 2, because we're going to have stretch this time. And what would be my axis of symmetry? I didn't ask that for the last one, but what would be the axis of symmetry on this one? X equals, it's always h. So what's h?
Negative 1.
Negative 1, so it's x equals negative 1. Because it's that vertical line that goes through the vertex. So I'm going to draw my vertex. My vertex is negative 1, negative 5. So I'm going to find that. That looks like it's right here. Okay, if I go right 1, 1 squared is what?
2.
But now I have a stretch factor, so instead of going up 1, I'm going to go up 1 times how much? 2. So I'm going to go up 2 because I stretch it by 2. Okay, if I go right 2, you drawing this trick? Get a pencil that works. Okay, so if I go right 2, 2 squared is
4.
But I'm going to stretch it by
2.
So instead of going up 4, I'm going to go up 8. So 1, 2, 3, 4, 5, Okay, I lost count because this thing's done. 1, 2, 3, 4, 5, 6, 7. Oh gosh, this thing's
What the
horrible.
heck? Get closer, man.
Yeah, is it at 3? I think it's at 3. Okay, so I'm going to call that enough on that side. Okay, and on the right hand side, it would just be flipped around. Or left hand side, I mean. Okay, and that is horrible tracing on my part, but yeah. I will try Ryan's idea. Every now and then Ryan has a good idea.
Are you sure about that?
Yeah. Here, maybe if I scribble a lot, it'll fix itself.
You just have to tell her is when you need some help.
Okay, we'll erase that. All right, what if I had a fractional one? So you might want your calculator handy if you have a fraction. Let's get our calculator handy. Yeah, sure. Okay, let's do y equals -1/2 parentheses x minus 4 squared plus 2. So what's my vertex?
-4.
Careful.
4.
Switch the sign on the h. So 4,
And 2.
2. What would be my stretch?
-1/2.
-1/2. And what is my axis of symmetry?
Four.
X equals 4. So I'm going to plot my vertex 4, 2. Here's my vertex, so plot our vertex. Okay, so from there, if I go right 1, 1 squared is,
9.
and then times my stretch. What's 1 times -1/2? -1/2. Are you with me on that or not?
Yeah.
So I go down 1/2. So this time I go down because it was negative. Okay? If I go right 2, so here I am, right 2. 2 squared is 4, but times my -1/2 gives me,
2. -2.
careful, -2, so I go down 2. So here are my points. If I go right 3, so I'm right here, 3 squared is,
9.
but times my stretch of -1/2 gives me
-4.5.
-4.5, so I'm going to go down 4.5. Now, if you get decimals, that's okay. And if I go left, it's just going to reflect. So I'll just copy those points carefully. Now I connect nice and smooth. And this one went down. So notice with the negative in front, it went down. All right. This is we're going to do more examples, but that's all that I'm going to record. So this is going to be an important fact that you get into your notes. If A is greater than, and I mean absolute value of A, is greater than 1, okay, that narrows my graph. And if the absolute value of A is less than 1, meaning it's a fraction, that that fattens my graph. Let's say fattens it.
Fattens it.
Makes it wider. Okay, next important point. If A is negative, so if A is negative, I open down. And if A is positive, I open up.